right? It says a change in y, as opposed to where the function is now. You're not trying to find approximate to f of x at one particular location. You're trying to see how far the function has moved. It's changed. Correct. Distance from a particular location, as opposed to actual location. So number 23. So we'll formula here. I want to approximate. These questions are pretty straightforward. Approximate the change in volume. Oh, reminds me of the test.
I know.
Approximate the change in volume. You guys know what the area of a circle is?
Nope.
Pi. Try to give the easiest question. Pi r squared. It's equal to 2 pi r, dadgummit.
2 pi.
That's the circumference. Right? It's not the area.
What's the circumference?
The distance around it.
That would be the derivative of pi r squared.
You remember that, yeah?
Extra credit?
10% bonus. Yes.
No, probably not. Approximate the change.
You won't give us that 10%.
I just maybe do something for you the way you guys are floundering.
Just do it because we chose you as our instructor first.
That was your mistake. Approximate the change in volume of a sphere. Sphere. When its radius changes. There's too many words for the simplest problem is. When its radius changes. From 5 feet to 5.1 feet. In case you're a total ignoramus, the book has gone ahead and given you the volume formula for a sphere. V of r equals 4/3 pi r. You ignorant.
What is R? Oh, radius.
Cubed, right? Remember, it's a volume, so the r has to be cubed to give you 3 dimensions.
So if it was 4 dimensions.
Was that?
So if it was 4 dimensions.
Then there'd be an R4 on there.
Whoa.
I don't know what the other numbers would be attached to it, but there'd be an R4. So there's our sphere. There's the volume of our sphere. We want to know approximately how much the volume changes. We want to know change in V, right? We want to approximate change in V, change in volume. When the radius changes from 5 to 5.1. So the radius extends a little bit, right? From 5 feet to 5.1 feet. Goes an extra 1/10 of a foot out. How much has the volume changed approximately? We want to find. Out of curiosity, do you know how to find the actual change in the volume?
No.
I'm just curious. What do you think you would do? You have the intellect and mathematical prowess and information to discover it. I'm just curious if you can put those together.
dy dx.
Would it be that relative rates?
Forget relative rates. It's so simple you might not even think of it. I just want to know how much the volume of the sphere changed.
Yeah, you just plug it in and you subtract it.
Correct.
And then you
That's
get it.
right. You plug 5.1 into here, compute. Plug 5 into here, compute, subtract. That's how much the volume has changed, right? So instead of doing that process, we're going to do something which is more cumbersome and approximate.
Why?
Because that's, I told you, you're getting very simple. It's like what we did before, right? We had the exact answer before. We're approximating the exact answer. I can compute the exact change right now. Why am I approximating it? Because there are going to be cases in the world where you can't do that. So you got to know how to do this in a wider
Yeah, can you
array of
give us a real
situations.
life example?
I just did.
No, you didn't. You just said there are going to be.
The case I just gave Roger, right? You got the curve, right? There's the curve. How? You know this value, and you know its slope, but you don't know what the curve looks like after that. But you want to know how much it's going to change. From here to here, you want to know how much it's going to change. So I can approximate that. I can get the point on the tangent line, and I can take the difference between these two, right?
That really depends on the function you're using is consistent throughout. Unless the piece, even when it's a piece
Correct.
function, you have
Correct. There are assumptions made about these types of functions and the kind of the properties of the materials you're dealing with and all these things, all sorts of assumptions. They're usually really good assumptions from lots of experimental work, right? They don't base it on nothing. They don't just like, I think it's continuous. Yeah. All right, approximate change in volume. We don't want exact, we want approximate. So that means we need f prime, which would be v prime. V prime
That was
at where though? What are you going to use? 5 or 5.1? They gave me two x values, so I used the 5 or 5.1.
5.1?
I used where I was. I used 5. Okay? Times change in x. So what's the change in x? 0.1. That's right. So we need v prime 5 times 5.1 minus 5, which is the 0.1 you just mentioned. That is our approximate change in volume. It's not the exact change in volume. So what's v prime? It goes from the volume of sphere. You take its derivative. It then goes to what? Surface of sphere. So 4 pi r squared. Right? Do a power rule, bring it down to 3, 4 pi r squared. So v prime is that, and you want to know it at 5. So v prime at 5 is what? 100 pi? Agreed? Okay, 5.1 minus 5 is 0.1. You already told me that. So we're just going to plug in the values here. 100 pi times 0.1 is our answer.
Why'd you put that on?
0.1.
I was like,
So
wait,
that- too much way of comparison.
Yeah.
So 0.1 times 100 is going to be a 10, right? So we have 10 pi. So now what are the units on that? 10 pi what? It's a change in volume.
Meters per second.
That's a change in volume.
Why did we measure the meters?
Well, first of all, we're using feet,
Oh,
Raja,
fine.
so it won't change something in meters.
Feet cubed?
Feet cubed, right? You know what we said? That's right, feet cubed. Just think about your units. You change the volume. The volume of a sphere is measured in the radius is in feet. Feet cubed. So 10 pi feet cubed is about how much the volume changed. Any questions on that?
Wait, what? The last sentence you said?
Any questions on that?
No, the second to last.
I don't remember.
Something about
You
changing.
said something about
Did I
feet.
say any questions on that twice? I don't remember.
Okay, so you said that the answer is 100 pi? I mean 10 pi?
It is 10 pi.
Feet
And
Oh,
units
it's
are,
feet.
Baker says the units are feet cubed, and he's correct, because it's a volume. So it must be a linear measure cubed. What was the linear measure we started with? Feet,
Okay.
right?
You know, we should be on the metric system. That's it.
America's getting there. Take your time. Take it. We change slowly, right?
About what?
We change morals every other day. But changing it, our system of measurement, that's going to be a while, right?
No.
Never gonna
It
happen.
should happen
You think
overnight.
so? Really?
Because first you have to deal with everybody who already doesn't know the metric system, i.e. all of our generation, plus the generation in school learning the metric, learning their feet and inches right now. Plus you have to change all the books over. Alright, that's gonna take another long time, and at that time there's gonna be another generation or so. So then
It's like
we
a lot
have
of
to
money, too.
constantly.
To change the metric.
So you're saying like,
Yeah.
Delete-
They're
delete-
not-
You also
they're
gotta
not
do
gonna
like
print a
road
whole-
signs.
No
yeah, they
way.
do road signs and cars. So was everyone trade in their 2015?
Ah, you already
for-
have kilometers per hour in your car. Yeah, you
Hey,
do.
dude, it's a smaller
It's
unit.
underneath.
Oh, you do?
Oh yeah.
All
See,
right. But then-
creeping in.
But then, but then you have the large miles
this
per hour.
There's meters
over
per
the
what?
kil-
Kilometers per hour in your car.
Yeah, there is. You know how it's like.